I'm Sushan and my team members are Jasmine and Geraldine. We'll be presenting our insights on the Green World project. This is the table of contents. I'll be touching on the first 2 points followed by Jasmine and Geraldine. To start off, I will now be explaining the differences between relational and non-relational database. First, relational database only deals with structured data, while non-relational database deals with both structured and unstructured data. This means that in relational database, the data is organized in tables, while in non-relational database, the data is in a document format which may not be clearly defined and organized. Second, non-relational database is more flexible. This is because relational database works by linking information from multiple tables through the use of keys. Therefore, if the data we are working on is simple and does not need to be related to other data, then non-relational database would be a better choice. Third, relational database is more costly and difficult to scale compared to non-relational database. As relational database is designed to run on a single server to maintain the integrity of table mappings, complex and expensive hardware with more processing power and storage is needed when scaling is required. On the other hand, non-relational database can run on multiple servers that work together. Lastly, relational database is better able to deal with complex queries if in-depth analysis is required due to the availability of its functions such as complex joins. Our group therefore thinks that relational database would be a better choice when dealing with our underlying dataset for this project, since the data is highly organized and have relationship with one another. I'll now move on to how Singapore have been performing in terms of energy consumption. Given the limitations of our dataset, the latest data we will use in our quantitative analysis is from year 2018 as there is no record captured for subsequent years. In the selection of our comparable reference, our group chose the top 3 countries with comparable GDP per capita as Singapore in 2021, based on external research. Our group then used the correlation test to see which countries have changes in GDP per capita over the years that is most closely related with that of Singapore's. Here, we use 10-year records from 2008 to 2018 for all our analysis, as we believe that the more recent data, the more relevant the data will continue to be beyond 2018. Therefore, we chose United States as our reference as it has the highest correlation with Singapore. Taking a look at the general trend of energy consumption per capita for both countries, Singapore has an overall increasing trend, while United States has an overall decreasing trend. This could mean that the average Singaporean is using more energy, but further breakdown on the nature of energy included therein is needed for more useful analysis. We see that the consumption of non-renewable energy per capita is much higher in Singapore. This is most likely due to Singapore's heavy reliance, as we found that non-renewable energy sources takes up close to 100% of Singapore's total share of energy. This is also evident in our analysis of renewable energy consumption, as Singapore consumes much less renewable energy compared to the United States. This suggests that United States is more proactive into switching to renewable energy sources compared to Singapore. Nonetheless, Singapore has also put in the effort to use more renewable energy sources, as shown from the slight increase in its consumption of renewable energy. In particular, the main renewable source for Singapore is solar energy, and we can see that there is an increasing trend in the consumption of solar energy over the years. However, given that non-renewable energy consumption is increasing at a much higher rate, it could mean that the availability of renewable energy sources from solar energy alone is not able to meet the increasing demand for energy. To determine whether our analysis continues to be relevant beyond 2018 and today, we shall take a look at the future plans for both countries. First, it's not feasible for Singapore to use wind and hydro energy due to our low wind speed and slow-moving water respectively. Second, we expect increasing consumption of biofuel energy in the future as energy companies like Shell aims to build biofuel plants to halve its emission. We also expect solar energy consumption to increase as Singapore plans to increase solar energy deployment to meet around 3% of 2030 projected electricity demand as one of its green planned targets. As for United States, we expect that it will continue to cut down on non-renewable energy consumption and move on to renewable energy sources, since it has initiated plans such as their solar energy and wind development goals. Therefore, we expect the trend in our quantitative analysis for the 10-year to extrapolate beyond 2018 for both countries, but with an even greater increase in renewable energy consumption. I will now pass the time on to Jasmine.
Thank you, Shisan. Moving on to the next section. Should Singapore go nuclear? First, let's take a closer look at some of the challenges Singapore faces with its electricity. Firstly, increasing demand. As you can see, Singapore's demand for electricity has been increasing since 2000, from 29 terahours to 53 terahours today, nearly twice the amount. Diving deeper and looking at the source of demand, we see that the industrial-related and the commerce and services-related sector seems to be driving this increase. And as of 2021, the industrial-related sector accounts for most of our electricity consumption at 41.7%. Going forward, Singapore's electricity demand is expected to increase at an even faster rate with increasing digitalization and technological advancement such as electric vehicles. Now, what about electricity supply? As you can see, Singapore's main source of electricity are from gas and oil. Over the years, we have been shifting our sources and relying more on natural gas to generate electricity. To date, 95% of Singapore's electricity is generated using natural gas, the cleanest form of fossil fuel, all of which we import from around the world. The heavy reliance on importing natural gas for generating electricity leaves Singapore's electricity supply vulnerable to development overseas. And while natural gas may be the cleanest form of fossil fuel, it is still carbon emitting. Hence, in the recent years, Singapore has been increasing its efforts in generating electricity from renewable sources, specifically solar and biofuel. This can be seen in the steep increase of usage in 2012 and again in 2016. However, despite current efforts, the potential for usage of renewable energy in Singapore is limited given our lack of clean and natural resources. Even solar energy, our most promising source of renewable energy, has its limitations and is expected to only meet about 10% of Singapore's projected electricity demand in 2015, and this is even after maximizing all available space. So, where does this leave us on our greenhouse gas emission? As expected, Singapore's greenhouse gas emission from electricity generation has been generally increasing. This is expected given our increasing consumption and continued reliance on natural gas. However, this cannot continue. As part of its long-term low-emission development strategy, Singapore plans to achieve net zero carbon emission by 2050. Now, more than ever, there is an increasing pressure for us to find an alternative source of electricity which is clean and efficient enough to meet our increasing demand. So, now that we have a better understanding of electricity in Singapore, should Singapore go nuclear? Well, to answer that, we first have to look at what exactly is micronuclear reactors. Now, I know whenever we think about the word nuclear, we think about the big nuclear plants. Well, micronuclear reactors is not that. Designed to be small, micronuclear reactors are portable nuclear reactors that can generate up to 20 megawatts of energy. To put it in context, they are small enough to fit on the back of a truck or a standard 40-foot shipping container and functions like a ready-to-use product. Some of its key features includes zero carbon emission, portable and quick deployment, and most importantly, it is reliable and efficient and is able to generate electricity and provide power 24/7, in contrast to current renewables, whose energy generation is dependent on conditions like the weather. So, assuming that micronuclear reactors have become environmentally viable and economically feasible for Singapore, our team thinks that yes, Singapore should go nuclear and that micronuclear reactors might just be the alternative electricity source that Singapore is looking for. While it definitely cannot replace natural gases completely, Macronuclear reactors is an efficient source of energy which can substantially supplement and increase our electricity supply, diversifying our sources of electricity and reducing our reliance on natural gas and import. Additionally, with it being a zero carbon source, macronuclear reactors is definitely a more sustainable alternative and will definitely help propel Singapore to achieving its goal of net zero emission by 2050. While micronuclear reactors is not renewable and hence definitely not as sustainable as renewable energy, our team believes that it is the bridge between natural gas and renewable energy, allowing Singapore to be more sustainable while we develop more technology which can, hopefully in the future, allow Singapore to fully sustain itself on renewable energy. Its portability and ability to fully function independently on its own is also perfect for the land-scarce Singapore, opening up many opportunities such as regional power grid and specific deployment in electricity-intense areas such as Tuas, Ubi, and Jurong Island. And with that, I'll pass on the time now to Geraldine.
Thank you, Jasmine. We'll now be looking onto the effect of greenhouse emission on climate change. And do take note that in this case, we'll only be using data from the year 1990s to 2014 due to the limitation in our dataset. So before going into the individual climate change issue, we'll first analyze the greenhouse emission trend, where you can see on the slide that the emission is increasing at a decreasing rate. And the dip in 2014 does not conclude that the current greenhouse emission is decreasing, but just the fact that it is lesser than compared back in the 1990s. And also, greenhouse emission is cumulative. Hence, we can recognize that the total greenhouse gases in the atmosphere is still increasing. And to better understand on the current trend, we'll next analyze the greenhouse emission from the generation of electricity from 2015 onwards. And the reason for choosing generation of electricity is because it's the largest source of greenhouse emission. And from the graph on the slide, we can see that there is an increasing trend. Hence, with an increasing trend of the largest contributor of greenhouse emission, it can imply that the overall greenhouse emission will still increase. And next, we'll go into the individual potential climate change issue. So the first issue is that we will analyze the effect against global average land temperature, where it is also an increasing trend throughout the years, and the temperature in 2014 is higher as compared to back in the 1990s, which could be due to the more greenhouse gases present in the atmosphere trapping more heat. And to go further into temperature, we'll now look at the change in temperature. On the change in temperature change, we noted there is also an increasing trend which is in line with the increase in global average land temperature earlier. Also, we noted that the change in 2014 is at least 50% higher as compared to back in the 1990s, implying that the temperature is currently rising at a higher rate. And moving on, we will look at the next issue, which is the extent of sea ice. So what is the extent of sea ice? The extent of sea ice is defined as the area in which at least 15% of the surface is frozen and covered by ice. So the graph on the slide shows that there is a decreasing trend, implying that more sea ice are melting, which could be the effect of rising temperature. So next, moving on to elevation change, in which is defined as the change in the thickness of ice, and in this case, we'll only implement data from 2000 onwards, as it was the most commonly referenced year in our dataset, implying its significance, hence taking it as our baseline year. So we noted that there is negative changes throughout the years from 2000 to 2014, which we could infer that there is a thinning of ice, hence the decreasing of thickness, and could likely to be an effect of the rising temperature. So lastly, we'll look at mass balance, in which mass balance is defined as the difference between the accumulation and the melting process. So we understand that glacier will gain mass through the accumulation process, and with it having negative mass balances seen on the graph throughout the years, we can conclude that the melting of ice is faster than the process of the accumulation of ice. To conclude, our overall analysis earlier showed the interrelations of the effect of greenhouse emissions on climate change, which in short could be understood as the increasing greenhouse emission could result in rising temperature, as there are more greenhouse gases present in the atmosphere trapping more heat, and the rising temperature would further result in the melting of glaciers, and lastly, the melting of glaciers would eventually result in rising sea levels. And some effect of rising temperature on the climate would be affecting the wildlife and destroying their habitats, as they are forced to shift to cooler areas, and it could also result in droughts that increase the risk of wildfires and the loss of crops. Whereas for the effect of rising sea levels, it could cause the flooding of small island nations, and species who are required to live in cold areas will be required to shift their habitats
such as spend grid. And one overall effect would be the increasing occurrence of extreme weather events, increasing the overall risk of natural disasters such as tornado and tsunami. And with that, we've come to the end of our presentation. Thank you.